In Lesson 3.4, you learned how to create multiple threads to speed up complex tasks. But the code that you added introduced something called a race condition. In this lesson, you'll learn about race conditions and fix the code to prevent one from occurring. To begin, open the Mathland project from your Sample Files folder. Now open primes.aspx and click Debug, Start Debugging. Now let's try to demonstrate the problem. In the maximum value box, enter 100 and click Calculate Primes. The calculation may work without any problems, but you may also find that no results are returned. This is also related to the race condition problem. Now try entering 100,000 and click Calculate Primes. This time, an exception may occur. However, race conditions are notoriously unstable, so the code won't behave in the same way every time. If you continue to click Calculate Primes, an error should eventually appear. But don't worry if it doesn't. All that's important is that you recognize that this code is not working correctly. Regardless of whether an exception occurs or not, close your browser and return to Visual Studio. Then open the code behind file of primes.aspx. To understand why this code isn't working, consider what is happening in the code. First, thread 1 begins, and while it is still running in the background, thread 2 begins. Without waiting for thread 1 and thread 2 to finish, the code then immediately attempts to populate the list box control with the results, even though the results are not complete. When you run a very small number of calculations, thread 1 and thread 2 can finish very quickly, so the results may already be complete before the code populates the list box. This problem is called a race condition because everything works perfectly if thread 1 and thread 2 win the race. They must finish before the code tries to display the results in order for the code to work. Clearly, it is necessary to wait until thread 1 and thread 2 are finished before populating the list box control. You're going to do this now to correct the error. Make sure that debugging is stopped and add the following code after the task thread 2 line. Thread 1 dot wait thread 2 dot wait. This very simple code will wait until both thread 1 and thread 2 have finished before continuing. You could also have done this using the task.waitAll method with the code task.waitAll new task thread 1 thread 2. Task.waitAll is useful if you have many task objects that are stored in a collection, as you can easily wait for them all to finish with a single line of code. Test your code now by viewing primes.aspx in your browser. Click Calculate Primes, and this time the calculation runs without any problems. Your code correctly waits for both threads to finish before binding the results to the list box control. The calculation also finished in just 18 seconds this time. It took 25 seconds when working with a single thread in Lesson 3.4. This may not seem like a huge performance increase, but the difference would be much larger if you were to calculate prime numbers up to 1 million, for example. The calculations finished faster because they were shared between the processors on my computer. If your computer only has a single processor, you might not see any performance increase, as your computer has to handle both tasks on the same processor. The task class is the newest and best way to implement multi-threading in ASP.NET 4.5. However, you'll cover the older thread and thread pool classes in the next few lessons, as you will probably encounter them in older projects. You're also going to take a closer look at the action class and its partner, the func class, in Lesson 4.11. Close your web browser now and close Visual Studio. You've now completed Lesson 3.5. Prevent race conditions when working with the task class.